Hello, welcome to the new initiative from Trade in Motion. I'm Gabriela Castro. We support companies to expand into North America. As mining is a key industry around the world, we help the mine teams to find the right product, service, or machinery to optimize their production and keep their personnel safe. Every Wednesday, a different technology will be exposed. Stay tuned. Today, the company Multotec will be showing its technology. Multotec helps mines across the world to process minerals more efficiently, effectively, and reliably. They partner with their clients to drive continuous process optimization to their plant with application of specific mineral processing solutions. They have a global footprint across Africa, Asia, Australia, North and South America. Réjean Foissy, General Manager at Multotec Canada, has 25 years of experience in the mining industry. Réjean has a bachelor's, master's, and doctorate in mechanical engineering and metallurgy. Mr. Foissy leads the Multotec Canada team since 2014. Réjean, please show us the benefits of using Multotec technology.
Good day, Gabriela. Thank you very much for the opportunity of presenting and introducing Multotec Canada as the leader in North America, which covers Canada, US, and Mexico. Today, I will talk to you briefly about sampling. Multotec worldwide is one of the major leaders in sampling. So we do respect all the rules of sampling theory presented by François Bongarçon, which is the world leader specialist in sampling. So let me share my presentation, Gabriela, if you don't mind. And,
yes, please.
Okay. Let me do my best to share it efficiently. Okay. So sampling. Basic of sampling. To be a sample to be correct must be when a fragment is from a lot to be sampled has the same probability of being selected in the sample at any moment of time. That means that a sample must be correct and sufficiently reproductive to be reliable, to let's say, show you and identify that your process is under control. And this has been identified by the worldwide specialist, Dominique François Bongarçon and Pierre Guy. So according to the rule of sampling. So the definition of a good sample, you have three ways of sampling something. Either you do it taking part of the flow, part of the time, or taking part of the flow all the time, or taking all the flow part of time. In all fairness, Multotec is using the third way of treating it, which is we take all the flow part of the time, which means that we're going to do a complete cut of the section, or let's say the slurry to be sampled. And from there, we'll do it every 15, 20 minutes and so on to be able to take a representative sample that will represent correctly your process. So I'm going to identify to you, why do we sample, how often, and when, where, and so on. So there is two types of sampling: process control or metallurgical accounting, or sometimes so-called process evaluation. In the process control, what we want to do, we want to obtain a mineral balance of the process plant itself. In other words, we're going to sample in various locations to see, for example, if your mill is operating correctly, or your crusher is operating correctly, or your flotation plant and so on is operating properly. On the other hand, when you want to do process evaluation or metallurgical accounting, you need to be more precise. Why is that? Because from the beginning to the end of the process, you want to evaluate what is your percentage of recovery. Is it 100%, which is what we all expect? which means whatever you receive with the ore you receive from the plant, at the end, you will collect exactly what you have measured at the beginning. If you have 6 grams per ton, for example, of gold into the process, at the end, you should have recovered 6 grams per ton. So that's what we call metallurgical accounting, which is different from process control. So in general, why do we, sampling is always something which is questioned by the plant because it doesn't bring a correct, or let's say an increase in production. No matter how often you're collecting sample and so on, you will never increase your production rate. However, if you produce more efficiently, then you will recuperate more. Your recovery would be better. And in that regard, sampling is very useful. So we need to do the sampling correctly, the right way, and also it will help the plant to do some decision makings in terms of increasing production or not. The difficulties is often with the variation of the ore grade that we are having. We have the final samples and composite that must be managed and identified properly. And all those things, according to the fluctuation of the variation of the run-of-mine material and so on, makes the sampling a necessity. In all aspects, we can sample in various locations, various streams, and so on, with the various frequency, with the cutter size, with the proper preparation, and so on. And all those things, all those parameters that are technical aspect that needs to be identified are identified with our experts at Multotec to help you choose the right equipment for the right application at the right time with the right cutter size and so on, according to your run-of-mine material. So all those critical decisions, that does apply multi-stage sampling or not? Are we going to select a big equipment or not? What is the cost of sampling and how it will affect the plant operation and so on. So from the theory of sampling, what do we measure? We are measuring the total error of sampling. We are trying to minimize the error by being able to reproduce efficiently and accurately the measurements. So that's why we are having machines and equipment that are giving us accuracy, which is being close to the truth of exactly what you have in your ore, the precision to be as close as possible. Every time you measure it or you take a sample, it must be representative of what you have in the process. So if your process is stable, all the collecting material should be in the same area. So, and the representativity is the combination of being accurate and reproductive or precise. Just to give you some example, and let me just skip that one because there's a lot of details and so on. So precision, what does it mean? For example, if we have poor accuracy and poor precision, you will have measurements all over the place. None of the measurements would be similar, and therefore that means that what you're measuring is more or less useless. When you have poor accuracy but good precision, it means poor accuracy. It means that you are far away from the true results, which is the bullseye, but you are reproducing it efficiently because every time you take a measurement, it takes the same one. So therefore, you have a good precision, which means that you have eliminated some of the errors that people can do by handling it and so on, but you are still far away from the accuracy that we're targeting for. So being accurate but not precise means that sometimes you're getting the true value of what you have in your ore, but you are not be able to reproduce it efficiently. By having a combination of good accuracy and precision, by having the proper equipment selected at the right speed and the right time frame and so on, you will get good accuracy and good precision, which would give you the true value of what you have in a good timely manner. And that's what the equipment or samplers are trying to reproduce. As an example, Let's say that you are collecting your ore every 120 minutes or 2 hours. That will give you values all over the place. The yellow line is representing, the upper limit, and this line here is representing the true value. So the closer you get, or the more sampling you do, the closer or the better you get accuracy and precision. To do that, physically speaking, with people, it will be very difficult. As an example, if we say that we're taking a measurement every 7.5 minutes or 15 minutes, as an example, to make a round number, every 15 minutes, you're taking a measurement. If the next day, people are taking it every 20 minutes manually instead of 15, it will deviate from the true value. So therefore, by deviating from the true value, you're losing precision. And by the same time, you're losing accuracy, because if sometimes you do it every 10 minutes, sometimes you do it every 20 minutes, sometimes you do it after an hour, and so on, you are not able to do any reproductivity whatsoever. To be able to do that, you need to use a sampling equipment, and that sampling equipment will give you the ability to reproduce the results, to be accurate, and to achieve a goal of not being biased. So that's what an equipment looks like. We have various applications for various locations in the plant. Usually when we take a primary, a sampler at the beginning, we call that the primary sampler. A primary sampler is taking sample, and I will give you an idea of what it looks inside. For example, you see here we have a sampler here, which we call a launder sampler, that is taking a sample from a belt conveyor. This is the cutter. So as soon as the slurry falls into the chute, the cutter that goes from left to right will collect the slurry itself. That slurry will be bring into a collector downstream. So that goes downstream, and from downstream, it goes into a jar that you will use in your lab for analysis. I have also videos that I can show you. So this is a cut view of how it operates. So you have your conveyor, the chute goes here, the cutter is right here, it goes from left to right. When the cutter cuts the slurry falls into a pipe, this pipe here, into a secondary sampler. Why a secondary sampler? Because when we do the design, some plants are requesting a certain quantity to be according to the rule, or let's say rule of sampling. The rule of sampling is saying you need to collect a minimum of 2 liters or 3 liters per hour, and so on. So if that's the case, and by collecting it according to your flow rate, your flow rate might be too high, and therefore you will collect 6 liters instead of 2. And therefore, to still be reproductive, you're doing a cut of the primary sampler into a secondary sampler, which is a second cut of the first cut, that will lower the quantity that you're recovering, but still be reliable. If you go from a primary sampler to a secondary sampler, you will have what we so-call multi-stage sampling. This is to lower the amount of material that you will collect. And that will be collected into a reservoir here. You see, you have jars that are collecting the material afterwards from the Visin sampler into the jars here. And that jar, you take it every 2 hours, 3 hours, you bring it to your laboratory for analysis, and then you can control your process efficiently. So you have also the combination of a primary sampler and a secondary sampler into the same unit that we call a 2-in-1 sampler. And that 2-in-1 sampler will work. Your slurry is falling into the pipe entrance here. You have what we call a collecting arm that will cut the slurry as a one-shot. You have the reservoir here, which is designed by our specialist to ensure that we're not losing any material. And that material will go down to a secondary sampler that will cut it a second time to ensure that the quantity that will be delivered at the end here is the quantity which is required as per the theory of sampling. Of course, the slurry within the 15 minutes, or let's say if we collect every 15 minutes, in between, the slurry will flow surely and freely between the entrance pipe and the outlet pipe. So this is the inside of a sampler. So this is what this is your entrance pipe, and this is the collecting arm from the inside with the cutter opening, which is sized according to the theory of sampling. Usually, when we have to design a sampler, we need to design it according to your plant and your needs and criteria. Your flow rate, as an example, which type of material, which type of flow rate, slurry rate, the pulp density, the temperature of the material, the size of the material, and so on. The size is very important in sampling because the cutter opening is always bigger or greater than 3 times the material size. So therefore, in that regard, it is what we are designing for. So that's why we need all those information from the plant people. I may just show you a small demonstration of how, let's say, a sampler operates from a video. I will try to look into that video. Sorry, let me try to select it. And then if people have questions, they can always reach me out. Let me try to share this. This will show you how a rotary sampler works. I hope you see it properly. So this is the inlet material that goes into the bins, and the bins will split the material from one entrance to the other, and that way you can collect samples within 2, 3, 4, 6 hours, 8 hours. And from there, it will give the people an idea of what they have to measure into their plant to control their process. Maybe I can try to show you another video if I'm able to share. Let's try to operate it. So this will show you how a hammer sampler works. So that's on a belt conveyor. We put one of the sampler on top of it. There is the cutter arm here with the cutter. The cutter will take a complete slice of the slurry or the dry material in that case, and the material is falling afterwards into the chute here to be collected properly. So I hope that clarifies, technically how a sampler works from a basic standpoint. Of course, there is much more details to talk about, but we have limited time here. So from there, if you have questions, please reach out through Gabriela, and we'll be able to return your calls and answer your questions properly.
Yeah, so thank you very much, Réjean. I think that you made a great and very clear presentation about Multotec products. And I think that mines in Mexico and around the world can benefit of the technology that Multotec can offer to optimize their operations around the world. Thank you very much for participating in this initiative. For everybody, you will find below our coordinates. If you have any questions, please reach us. Thank you very much, Réjean.
Thank you, Gabriela. Thank you all. Take care. Bye-bye.
Thank you.